When we want to make a responsive, interactive program, if tests are absolutely one of the great things to use. We've seen that the tests inside of an if can be built up from comparisons of numbers and logical combinations of those comparisons like and or, and not. There's one other popular way to get more power out of an if test, and that's by combining them. Often we call a combined if test a compound if test, and it just means putting together several if tests, usually according to one of two general recipes. So in this video, we will look at the two recipes for compound if tests. I want to demonstrate this by using a nice graphical example, so we'll talk about whether a point is in a box. So let's imagine we have this routine lying around, and we saw earlier how we might write such a thing. It's a Boolean function, so it returns a Boolean. Its name is point_in_box. It takes 6 floating point numbers, the x and y of a point we're testing, and then 4 numbers describing a box, the left, top, width, and height. This is a long line, and it's going to take up a lot of room in our examples if I type all this out every time. So I'm going to really abbreviate it, and I'm just going to call it point_in_box, where I'll just spell point with PT, and I'll only have 2 arguments. The first is P, and I'm writing it in italics to remind us that's really point X comma point Y. And then the second argument will be a box, and I'm numbering them. So it'll be B1, B2, B3. And again, that's in italics, so that's to remind us that that stands for 4 numbers. So when you see this point, comma, box business, you know I really mean the thing on top. I mean 6 numbers are going in. I just don't want to write them all on every slide because that's not what I want to focus on. So to really cement this, let me show you how we might use this little shorthand. Here's our screen, and we have a point P, and we want to know if it's inside of box 1. So we can just call point_in_box P, comma B1, and that will be true if the point is in box 1 and false if it's not. We might also have a second box, box 2, and then I can call point_in_box P on B2, and that will be true if we're inside of box 2 and false if we're outside. So that's our shorthand, and it's just the shorthand for these slides. When we call point_in_box, we are really going to give it all 6 values that we saw in the previous slide. With that shorthand in place, let's look at the 2 ways we typically group if statements. The first is called choosing. Suppose that you had a screen that looked like this. You've got 3 different boxes, and you want to know if the point P, maybe that's under control of the mouse, is inside of box 1, or box 2, or box 3. So how might you do it? Well, if you were just kind of getting started, you might write if point_in_box P B1, and remember that the test has to be within its own parentheses, so there's 2 parentheses there at the end. So if the point is in box 1, okay, then we do something related to being inside of box 1. You get points, or somehow it responds to that. Now we can test to see if the point is in box 2. And if it is, you get box 2 points. Finally, we can test to see if you're inside of box 3. And if you are, you get box 3 points. And then finally, if you're not in any of the boxes, then you get generic points due to not being in any box at all. Wait a second. That's not going to work. The problem is that very last line, the one I just put the X over, that's always going to get executed. We only want that line to get executed if you are not in box 1 or box 2 or box 3. But the way it is now, that always gets executed. So how do we rewrite this in such a way that the thing I've X'd out gets executed if none of the others get executed? There's another issue here too. Suppose that box 1 and box 3 overlap. Let's suppose that box 1 is on top of box 3. If you have a point that is inside of box 1, but is also within box 3, this code will execute the code for being inside of box 1 and the code for being inside of box 3. And sometimes that might be exactly what you want. But in a picture like this, where box 1 is overlapping box 3, I'm going to say, I only want box 1. If that takes priority. If you happen to be in box 3 too, that's nice, but I don't care. So we have two problems. We have this overlapping problem where the code for both box 1 and box 3 will get used, and we've got this extra thing at the end that is going to get executed every single time, when really we want it only to be executed when we're outside of all the boxes. It turns out we can fix both of these problems in one solution. It's very nice. All we have to do is use the else clause that we saw when we talked about if statements. So let's go ahead and put in else at the end of the first one and move the second one up. What do we have here now? Reading from the top, if the point is in box 1, we execute the box 1. Else, so only if that's not true, we then look into box 2. Well, we can do that again. Let's put in else at the end of box 2. Now we've solved our overlap problem. Because look at where the point is. It's in box 1 and box 3. Reading from the top, we say if point is in box 1, oh, it is, and we execute box 1. And we're done, because we never look at the else. Because the else only gets executed if the test was false. And so all the rest of that stuff gets ignored. If we continue and put an else clause at the end after the box 3 thing, and notice that we need an open curly brace and then a closed curly brace at the end. Well, now we've completely solved both of our problems, and this not in any box thing is going to work perfectly. Suppose that the point is not inside of any box. Reading from the top. If point in box 1, nope, it's not. So then we do the else. If point is in box 2, no, it's not. So we go to the else. If point is in box 3, no, it's not. We go to the else. And now we execute the line that's in the white box, the line we execute if we're not in any box. So really the way to think about this is you start at the top and you're just choosing one of these selections, box 1, box 2, box 3, or nothing. And the sequence in which you test them is the sequence in which they get matched. And the first one that matches ends the whole shebang, and it jumps down to the last curly brace. So this is your recipe. This is the template for choosing among multiple things. So you might use this, for example, if you had an arrow shooting game. The target, which is a series of nested rings, a bullseye, is moving around, and the user clicks the mouse at just a given moment. And you would test first for the bullseye. If you're not in the bullseye, you test the next circle out, and then the next circle out, and the next circle out, giving the user fewer and fewer points as you get further and further away from the bullseye. This kind of thing, if, else, if, else, if, else, chaining together if and else, is used all the time. It might look a little weird, but if you try this out a couple of times, you'll see it's a very natural way. You're just choosing amongst a list of choices. I said at the start of the video that there were two ways that people typically build compound if statements. This was the first. In part 2, we'll see an alternative.